Okay, so the other day we saw that you can use MATLAB with vector valued functions to make space curves, right? And now what we're going to do is we're going to look at how do I make a surface using a multivariate function. So the way this works is that you get an x and a y value, and that returns a z. So x and y gives you a particular place on the floor, and z gives you a height for the curve. So the first thing I need to do is I need to establish the floor. And I'm going to do two of the problems from your problem set here, which are numbers 1 and 6. In all of these problems, you're using -10 to 10 as the floor. So what we have to do in order to get the floor is to make what's called a mesh grid. So we're going to go -10 to 10 in the x direction, -10 to 10 in the y direction, and then we're going to combine them and make a grid, which will make the floor. Okay, so I'm going to use little x, and I'm going to say little x is going to go from -10 with a 0.1 step size to 10. Oops, I probably should have hit the semicolon there, so let's clean this up a bit, and there we go. Aha, there it is with the semicolon. All right, so y, we're going to go from -10 with the 0.1 step size to 10. Don't forget the semicolon. There we go. So I used little x and little y for that. Now, in order to make the mesh grid, the floor, that's where I'm going to use the big X and the big Y. So this thing is going to output, so note I have like a 1 by 200 here for little x. That's just a list of 201 numbers. Little y is a list of 201 numbers. What I want is all of the x values for 201 to 201 and all the y values on a 201 to 201 grid. So that's what I'm going to get in the big X and the big Y here. The command for doing this is called mesh grid. And I'm going to have the inputs to that command be little x and little y. So I'm going to take the two lines, the x-axis and the y-axis, and I'm going to put them together. I'm going to get a plane. And if you look, it just made big X a 201 by 201 matrix. Big Y is a 201 by 201 matrix. So that's all the points in the floor that are 1/10 of a unit apart. So 100 points per little square, right? All right. Okay, so those points are my inputs. Now I'm going to put those into an output function. Now I know in the page it's calling it F. I'm going to call it Z. That's just out of habit. And Z is going to be the absolute value of X plus the absolute value of Y. Nope, that should be big X plus the absolute value of big Y, which now made a 201 by 201 matrix for Z. So it's all the heights at all the points. And now we want to plot this as a surface, which is actually really easy to do in MATLAB because the key word here is surf. That means make a surface out of big X, big Y, big Z, and when I hit enter, there it is. So I'm going to turn my 3D rotation tool on here, and I can move this thing around, and that's the surface that represents this thing from -10 to 10. Now, on the height, it's going from 0 to 20. It's 0 at the middle. The absolute value of 0 is 0 plus the absolute value of 0 is 0. On the outsides, I'm like adding like 10 and -10 or 10 and 10. You can see the bottom is a grid running from -10 to 10 and -10 to 10. So the origin is like right there at 0, 0. All right, so this is my three-dimensional surface. Kind of neat. All right, so that's problem number 1. Problem 6 does the same function, but it wraps it in the sign. Now, I don't have to reestablish the mesh grid every time. I can just regraph the surface. So if I now make Z equal to the sine of the absolute value of X, big X, right, plus the absolute value of big Y, right? So now I just reestablished all the Z components, and I can go surf X, Y, Z, and now it graphs new surface. That was a little interesting, right? Kind of undulating thing here. So you can see it's a sine curve. It's going between -1 and 1. stopping with the 0 in the middle. And it's just kind of, going up and down as it goes along. So this is the type of thing that we study in multivariate calculus, our multivariate functions, and this is how you get a graph of one. I can't imagine trying to draw that by hand. It would be kind of interesting. But MATLAB gives us the ability to kind of visualize these things, which is a really powerful tool. All right, so there you go. I'd like you to try all of them from the problem set and see if you can't make some sense out of this. Okay, thank you.